I'm Kyle Grafmeyer, and I'll be recreating Galileo's rolling ball theory. In it, Galileo disproved Aristotle's theory of motion and showed that gravity is constantly exerting a force on us. Aristotle believed that all matter has a place which a sea can move to, i.e. a rock falls to the ground because that is their natural resting place. An object only resists this movement when we exert a violent force against its natural movement. According to Aristotle, a ball only comes to rest because we are no longer exerting a force upon it. Galileo disagreed with Aristotle. He is able to prove that due to an object's inertia, the ball would continue to roll forever until stopped by a force such as friction. So he got a ramp, cut a groove in it to create a straight track for the ball to travel in, i.e. the poles in my experiment. He then got a water clock so that he could measure how long it took for the ball to roll down the ramp. This is the general idea behind Galileo's water clock. He used a water clock because, unlike today, he didn't have a stopwatch. It works using something that causes water to flow out constantly into another container. Galileo would then use a baseline for how much water flowed out per given amount of time. I measured that using this water clock, the water flowed out 900 milliliters per minute. When rolling the ball down, he will let the water flow out and measure it to his established baseline to get a time. It is comparable to an hourglass, but instead of sand, it uses water. I started this experiment by having the ball roll down the ramp entirely. I repeated this experiment 3 times. The water clock flowed out an average rate of 53 milliliters per test. I then repeated this experiment, but instead had the ball roll down halfway down the ramp instead of fully. I repeated this 3 times, with the water clock flowing on an average of 29 milliliters per test. Despite the inevitable inaccuracies that come along with using a device as imprecise as a water clock, one can see that the ball did increase in speed as it went down the first half of the ramp compared to half of the results of the first test. If the balls were rolled down at a constant rate, the water should have flowed out 58 milliliters in the first test instead of 53. Galileo proved there was a constant acceleration acting upon the ball, causing the speed to increase at a constant rate. The impact of Galileo's experiment was that it disproved Aristotle, who during Galileo's time many believed to never be wrong, and helped spark a rejection of Aristotelian logic over the next 2 centuries, causing a large increase in empirical science. It also laid some of the groundwork for Isaac Newton's laws of motion, mainly his first law, the law of inertia. Although a seemingly trivial experiment compared to today's technology and theories, it was one of the most important and influential experiments and theories of its time.